In the given example, if F equals to 100 Newton and C is the midpoint of a string and mass of a string is 2 kg, then we have to find the acceleration of each body and B tension in the string at C. The situation is shown in the figure. That is, this is a body A is of mass 2 kg and body B is of mass 4 kg, and it is connected with a string of mass 2 kg. Then we have to find the acceleration of each body and tension in the string at point C. Now this can be considered as a single body to find firstly its acceleration. So, and here we have to also consider the mass of a string to calculate the acceleration, and we consider 3 points, that is one point at this point, at C at this point, as C dash at this point, and uh, and then we can draw the free body diagram and solve the problem. So let us consider the acceleration considering this as a whole body. We can write if we considering whole body as a single body, then we can write sigma Fy equal to mass into acceleration, and there is one force in the upward direction and weight of the body is in downward direction and body is moving in upward direction. So we can write F minus ma plus mb plus ms into g, where ms is the mass of a string, equals to ma plus mb plus ms into a, and this gives a equals to F minus ma plus mb plus ms into g divided by ma plus mb. Solving, putting all value, we get 20 by 8 equals to 2.5 meter per second. That is, whole body is moving, that is body A, string and B are moving with this acceleration. Now consider the FBT of point C. This is the situation shown in the example. The here, if we cut from the middle point, then the mass of the string will be ms by 2, and if we consider, then the tension in this string is in this direction and this is written as Tc, and weight will be in downward direction, that is weight of string and weight of this body. And because this body is moving in upward direction with acceleration a, which we have calculated here in the free body diagram of point C is drawn. Here we see that this is the weight of a string and this is the weight of block, and tension in the string is in upward direction. So we can write this formula sigma Fy equal to m into Ay. So if we considering upward direction at positive, Tc minus ms by 2 into g plus mb into g equals to total mass into acceleration ms by 2 plus mb into a. This gives, this implies Tc equals to ms by 2 plus mb into a plus ms by 2 plus mb into g. Taking common from both term, we get ms by 2 plus mb into a plus g, and 2 by 2 plus 4 and 5 by 2 plus 10, because we have calculated a equal to 5 by 2 and here g is taken at 10. Then solving, we get 62.5 Newton. That is, tension at point C is 62.5 Newton. Now take the free body diagram of body A. The free body diagram of body A is shown. Uh, Force is acting in upward direction, and tension on this body is in downward, which is Tc dash, and weight of body is in downward. And again we can use this formula sigma Fy equal to my F minus Tc dash ma into g equal to ma Tc dash to F minus ma into g minus ma, or F minus ma into g plus a. Solving, we get about 75 Newton as answer. Now third case, Now FBD of B. Here FBD of B is shown. Again we can see that the body, we have taken the C double dash point. So tension in body B is in upward direction, and weight of body B is in downward direction, and acceleration of body is in this direction, upward direction. So we can write again sigma Fy equals to m into Ay, or TC double dash equals to minus m into G equals to m into A. TC double dash equals to m into G plus A. And putting all value, we get 15 Newton answer. Now problem related to pulley. They are a condition in this case, that is pulley are of negligible mass. Rope or a string is also of negligible mass, and friction between a string and pulley is negligible. Hey, like negligible. Now we see that, and different body moves with same acceleration. This is the condition here. For example, in this case, uh, pulley of negligible mass, and there is no friction in string and pulley, and also a string is of negligible mass. There is no mass of a string. Then we have to solve this problem, and this can be solved directly by using shortcut method. We can find the acceleration writing unbalanced weight divided by total mass to be pulled. Unbalanced meant be there will be two weight here. This is a weight and this is a weight. Unbalanced, that is one weight, the bigger weight, there we should uh, subtract a smaller weight from bigger weight, and this will be the unbalanced weight. And the total mass to be pulled will be total mass connected to the pulley, that is this mass and this mass. And so we can write directly this formula: A equals to 2 mg minus mg, this is the unbalanced weight, and divided by m plus 2m equals to mg by 3m equals to g by 3. So acceleration in this system body is A, but this body is moving in this direction with acceleration A, and this body is moving in this direction with acceleration A, and because both body will have same acceleration. For example, here it is shown situation. There are three bodies. Two bodies are connected with one string. A and B connected with this string, and B and C connected with this string. So tensor will be different in these two strings because strings are different. Now we can use above formula, net pulling weight. The net pulling weight will be 6, because this is pulling, the 6 plus 4 are minus 2 into G, and divided by total mass, and total mass is 6 plus 4 plus 2, so we get A equals to 2 by 3G. Now to calculate tension. Now FBD of 2 kg block, FBD of 2 kg block, we have considered the string tension in the string as T1. So T1 is in this direction, and acceleration of this block is in this direction, and weight is acting in this direction. So we can write sigma Fy, use the formula sigma Fy equal m into A, and this is considering positive, this is as negative. So T1 minus weight of this body equals to mass of this body into acceleration. This gives T1 equal to W plus ma into A, or ma into G plus, because weight equals to mass into acceleration due to gravity, ma into G plus ma into A equals to ma into G plus A, putting the value 2 into 10 plus 2 by 3, because we have calculated acceleration as 2 by 3G. So using all value, finally we get 100 by 3 Newton. So that's so the tension in the first string is 100 by 3 Newton. Now Consider the FBT of free body diagram of body C. Here, the that is body C is of 6 kg weight, so weight is in this direction, and tension is in that is in the second string. Tension for this body, tension is in this direction, but acceleration is in this direction. We can write sigma Fy equals to mass into acceleration. Here we are taking the direction of acceleration as a positive, so this also will be positive and this will be negative. So WC minus T2 equal to MC into A, that is weight of block C, and MC into G weight minus T2 equal to MC. Putting the value of A 2 by 3G, we get T2 equal to MC into G minus 2 by 3G, or T2 equal to MC into G by 3, or 6 into 10 by 3 equal to 20 meter. So from this we have directly calculated the value of tension. Again, next problem we see. Here the situation is shown. A 2 kg block is connected like this. This is the pulley, and all mass is the pulley is massless and the string is also massless, and there is no friction between pulley and the string. Here will be this again we use the formula, that is net pulling weight divided by total mass to be wheel. The net pulling weight will be 4 kg minus 2 kg into G, 4 into here the because this weight is balanced by reaction force, so this will not come in the picture. Only net pulling weight will be due to this. So net pulling weight is 4 into the weight of this body, and divided mass, total mass 2 plus 4, or 2 plus 4 equal to 6. Because here its weight is balanced by normal reaction, so we have not taken this weight in the pulling net pulling weight, and we get A equals to 20 by 3 meter per second. So both body will move with same acceleration. This body will move with this acceleration in downward direction, and this body will move in horizontal direction. Now ability of A, because only in the horizontal direction only one force is acting, that is tension, and there is no need to draw the diagram of vertical direction because body is not moving in vertical direction. So T equals to, using sigma factor to m into x, T equals to m into acceleration, the value, putting the value, we get 40 by 3 Newton. Next, ability of body B, that is this is the tension in upward direction and weight is in downward direction, acceleration in downward direction for block B. Now we can use sigma Fy equal to MAY, or WB minus T equal to MB into A, putting the value of A, that is T equal to WB minus MB into A, MB into G minus MB into A, or MB into G minus A, putting all value, you get 40 by 3 Newton as answer. Next, find the acceleration of each blade as shown in the figure and tension T. The body mass of body, this is body B of 1 kg and it is of 4 kg. Again we use shortcut method, A equal to net pulling weight divided by total mass of the body. So MB into G, this is MB into G. We have considered that this is pulling in this direction, acceleration in this direction. So this body will have acceleration in this direction. So we have taken component, that is if this is 30 degree, then this also will be 30 degree. So there will be two component of MB, that is weight. one in this direction and another in this direction, and this direction weight is balanced by normal reaction, and this direction weight is pulled by tension. So net pulling weight will be mb to g, this is pulling, and ma into g cos sine 30 degree, sin 30 degree divided by ma plus mb, which comes out to be minus 2 meter per second. Since a is negative, so the direction of acceleration will be opposite to our assumed direction, because we in the answer the value of a have come out to be negative, has come to negative, so the direction of a is opposite to our assumed direction. Now FBT of a, we have tension in this direction and mg ma into g sine 30 degree in this direction, mj this is, and this is this direction is balanced, this force is balancing this force, there is no movement in direction, only movement in this direction. So taking this direction, we can write FBD of a as a ma g sine 30 minus t equal to mass into acceleration. Net force in this direction equal to mass into acceleration. So directly we get t equals to ma into g sine 30 minus a. Putting all the value, we get t equals to 12 Newton. Again drawing the FBD of b. The t is in upward direction and the g that is weight in downward direction. Putting all the value, we get 12 Newton. Note, if we do not reverse the assumed direction of acceleration, then for the motion of body A, this equation will be t minus ma into g sine 30 equal to ma into a, and t equals to ma into g sine 30 plus ma into a, ma into g sine 30 plus a equals to 12 Newton. And similarly for body B, we get like this, ma g minus t equals to ma into a, and from this t will comes out to be 12 Newton.